graph them and use their coordinates to help us prove that it is a parallelogram. So there are 5 ways to prove a quadrilateral is a parallelogram. I know. So one way is if both pairs of opposite sides are parallel. I'm just going to use the symbol for parallel. So if both pairs of opposite sides are parallel, then the figure is a parallelogram. So in our picture up here, if we have AD parallel to BC and AB parallel to DC, then I could say, yes, that is a parallelogram. The next one is if both pairs of opposite sides are congruent. Okay, so if I have AB congruent to DC and AD congruent to BC, then that would be a parallelogram. If you're only given one opposite side congruent, you can't prove it's a parallelogram. They have to have both. The third one, if both pairs of opposite angles are congruent, then it is a parallelogram. Okay, so if I have all of angle D here congruent to all of angle B, and angle A congruent to angle C, both pairs of opposite angles have to be congruent in order to say that is a parallelogram. The fourth one, if the diagonals bisect each other, it is a parallelogram. So if I knew point E here was a midpoint of AC and of DB, okay, it has to be the midpoint of both of those diagonals in order for you to say, yes, this is a parallelogram. Then the last one, if one pair of opposite sides is congruent and parallel, then you can say it is a parallelogram. So if you have your picture here, and I just say AB is parallel to DC, so I have those arrows in to say that those are parallel. And I know that AB is congruent to DC. I can say that that would be a parallelogram. Okay, so if that one pair is parallel and congruent to each other, it does have to be a parallelogram. So those are 5 different ways to prove it is a parallelogram. So with the problems underneath there, we're given a picture and we have to state if it is a parallelogram, okay, using those 5 properties. So this first one, in my picture, I have one pair of opposite sides parallel and congruent. Would this be a parallelogram? Yes. Which one of my properties would that be? The 5th one. Okay, so I can say, yes, this is a parallelogram, since one pair of opposite sides is congruent and parallel. Okay, so you want to write out that reason why if you say yes. Okay, the next one to the right there. In my picture, I have these 2 angles congruent and these 2 angles congruent. Would this be a parallelogram? Yes. Which reason? Number 3. So I can say, yes, this is a parallelogram. And I just write out what it says in number 3. So since both pairs of opposite angles are congruent. Okay, I want you guys to do the ones labeled 9 and 10 there. I reorganized this note sheet and I forgot to change the numbers. All right, so is number 9 a parallelogram? No. Okay, this one is not a parallelogram since only one pair of opposite sides is congruent. Okay, you need to have both pairs of opposite sides congruent in order for it to be a parallelogram. In this one, you only have one. So then in number 10, would that one be a parallelogram?
Yeah.
Yes. Okay, in this one, you do have both pairs of opposite sides.
Doesn't look like one.
Yeah, it does. Okay, does that make sense how to use those properties to determine whether it's a parallelogram or not?
Yeah, I'm not trying to leave her alone.
No, you are leaving early.
No, you said be done at 8:10.
I said leave at 8:10. All right, so moving on here, on the coordinate plane, to find out if a quadrilateral is a parallelogram, you can use the distance formula, the slope formula, or the midpoint formula. Today we're just going to go over distance and slope, but you can use the midpoint formula. You would just have to find the midpoint of both of the diagonals after you graph it in order to prove that. So if you flip over to the back here, so for this example, we want to determine whether ABCD is a parallelogram given those vertices. Okay, and it is graphed off to the right already for you. So the first method I want to use is the slope formula. So what we're going to do is find the slope of each side of that quadrilateral. So we want to find the slope of AD. So this one right here. So I can use points A and D in my slope formula here. So that's your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'll take D as my y sub 2 here. So I'd have 0 minus, we're going to A, 3, over x sub 2 is negative 3, minus x sub 1 is negative 2. Okay, so I end up with negative 3 over negative 1, which is just 3. So yes, you can just use the slope formula, or since you do have your picture off to the right here, all it is rise over run. So for BC, we can go from point C to point B. Our rise is 1, 2, 3. And then we go right 1. So our rise is 3, and then right 1. So you can just use your graph to figure out that slope of that line. Same thing with AB. So AB is right here. If I go from point B to point A, I rise 1, right? And I go left 1, 2, 3, 4, 5. So since I'm going left, that'll be negative. Same thing with CD. So from C, I have to go up 1. That's my rise. Over my run is 1, 2, 3, 4, 5. So again, negative 5. Now when you're proving this is a parallelogram, you need to look at opposite side slopes. So that's why I have it laid out this way. So I have AD and I want to compare it to BC. Well, those two slopes are the same. If you have the same slope, that means your lines are parallel. Okay, that's why we can use the slope formula. So I want them to be parallel. Same thing with AB and DC. I'm going to compare those, make sure their slopes are the same, so I know those two segments are parallel. So since your opposite sides have the same slope, I can say AB is parallel to CD and AD is parallel to BC. Therefore, ABCD is a parallelogram because I do have both pairs of opposite sides parallel. Okay, that was the first one on your property table thing in the front. Okay, when you do this, say on your quiz, because you probably will have a problem like this on your quiz, you do need to write this part out here. Don't just write down the slopes and then say nothing about it. Okay, so you want to say what you saw between the two slopes. So you compared AD and BC, they were the same, so those lines have to be parallel. Okay, so just kind of writing out why it would be a parallelogram. Make sense? So that's the first method, using the slope formula. The second way is to use the distance formula. Okay, and we're going to use our same points from up here down here. Okay, and I do have the distance formula laid out right there for you. And we want to find the distance of all four sides of this quadrilateral. Okay, so first I'm going to find the distance of AB. So I need point A, which is -2, 3, and point B, which is 3, 2. And I want to plug those points into my distance formula. So I'll have the square root of x sub 2, so I'll say 3, minus x sub 1 is -2, that quantity is squared, plus y sub 2 is 2, minus y sub 1 is 3, that quantity is squared. Okay, so you're just plugging in those points into that distance formula. Okay, then I just want to simplify, so I have 3 minus a -2. That is 5 squared, and 2 minus 3 is -1 squared. So I end up with the square root of 25 plus 1, which is the square root of 26. I'm just going to leave it like that because, again, I want to compare opposite sides. Okay, so that was side AB. The side opposite AB is side CD, so I want to compare that distance next. So I need points C and D for this one. So point C is at 2, -1, and D is at -3, 0. And you don't have to write them down again. It's easier for me to explain when I put it here. So again, using our distance formula, we can take x sub 2. So we have -3 minus x sub 1 is 2. That's squared. Plus y sub 2 is 0 minus y sub 1 is -1. That quantity is squared. Okay, so I have -3 minus 2. That's -5 squared. Plus 0 minus -1 is 1 squared. So I end up with the square root of 25 plus 1, which is the square root of 26. Okay, so far so good. My opposite sides here, I am comparing these. They are the same, meaning those two segments within my quadrilateral are congruent to each other. Okay, so good start. I want you guys to do segment AD and segment BC. Find the distance of those two and then compare them. And then we'll come back together. You have to show the work. It's a proof.
Don't say that word.
It is a proof. It's an algebraic type proof, but it's still proof. You're proving why a quadrilateral is a parallelogram.
Because opposite sides have the same slope.
Yeah, I know, but you have to, I'm going to show you both ways.
Sure.
No, she's with Mr. Minton. Yep. Yep. All right, so what? So you should have gotten the square root of 10 for both AD and BC. So again, you're comparing your opposite sides. So since they do have that same distance, that means they are congruent to each other. So for my concluding sentence here, I can say since both pairs of opposite sides have the same length, then AB is congruent to CD and AD is congruent to BC. meaning this would have to be a parallelogram because both pairs of opposite sides are congruent. Okay, so you just, again, make sure you write out this concluding sentence explaining why it is a parallelogram, and then your work just shows the rest of the reasoning. Okay, so you just have to refer back to your algebraic work. Does that make sense? Any questions on those two methods?